Okay, hello everyone. In a new video. In this one we are going to explain chapter 2 in the first unit, which is the unit of optics. The title of this chapter is Formation of Images. So basically in chapter 1 we have developed all the ingredients that will allow us to study the properties of lens and its image from a geometrical point of view. Then let's start by section 1, Formation of a real image. So here the image is denoted by A prime, B prime, okay? So given the optical system of a converging lens, the direction of propagation of light is from left to right, and the optical axis has the same direction of propagation of light. And the lens here that we are using is a converging lens perpendicular to the optical axis at the optical center O. Now f is the object focus and f prime is the image focus, and we know that they are symmetric with respect to the optical center O. Okay, so what does AB represent? Let's write down that AB is a luminous object placed in front of a converging lens L. Okay, so this is the lens L, and because the direction of propagation of light is from left to right, then this side is set to be in front of the lens and this side is set to be behind the lens. Okay, now this is the object AB. Here AB is a luminous object, and the word luminous means that it's made up of light. Okay, so because the object AB is a luminous object, then it can emit light in all directions like this. But because the direction of propagation of light is from left to right, then we will be only interested in the light rays that are propagating from left to right and issued from the object AB. And the object AB is perpendicular to the optical axis at the point A. So let's say perpendicular to its optical axis, x prime x, at A. And let's consider incident luminous ray issued from the point B only. So incident luminous rays are issued from B, and they emerges through the lens. Okay, so the first incident luminous ray issued from B is parallel to the optical axis, and we know that it will emerge passing through the image focus. The second ray that is issued from B is passing through the optical center, and we know that it will emerge without deviation. And the third ray, which is issued from B, is passing through the object focus, and we know that it will emerge parallel to the optical axis. So as you can notice here that the point P represents the intersection of the incident rays. Okay, so notice that all of these rays are incident rays because they are hitting the lens, and the point B represents the intersection of these incident rays. So let's write down the object B of B prime is the intersection of the incident rays. Okay, moreover, the point A represents the foot perpendicular of B on the optical axis. Then let's write idea number 2, that A is the foot perpendicular of B on the optical axis. Okay. Now B prime is the image. Okay. Image of which point? Of the point B. So because the point B represents the intersection of the incident rays, so B prime will represent the intersection of the emergent rays. Okay, these are the emergent rays because they are coming out from the lens. Therefore, the point B prime will represent the intersection of the emergent rays. Okay, so let's write down idea number 3. The image B prime of B is the intersection of the emergent rays. Notice that here a hat is found on B directed away from the optical axis like this. Then we must place a hat on B prime directed away from the optical axis like this. Then let's place the hat. Now what does the point A prime represent? Notice that here the point A represents the foot perpendicular of B on the optical axis. Then the point A prime will represent the foot perpendicular of B prime on the optical axis. So this is the point A prime. And now let's write down that A prime is the foot perpendicular of B prime on the optical axis. Okay, and now let's trace the image A prime B prime. Okay, so this is idea number 4. Now notice that all the incident rays that are coming from B emerges from the lens going to B prime. Then let's write down the statement that all incident rays issued from B emerges going to B prime. Okay, and this statement holds not only for the 3 particular rays that we have drawn here, but for any ray that is issued from B. So let's consider an incident ray issued from B and hitting the lens at this point. Then we will know that it will emerge going to B prime. Okay, and we don't forget arrows on light rays, incident rays, as well as emergent rays. Okay, we can consider also another incident ray issued from B hitting the lens at this point. We know that it will emerge going to B prime. Okay, so now we are able to complete the path of any arbitrary ray issued from B because we know the image B prime of B. Moreover, notice that the object AB is pointing upward, and the image A prime B prime is pointing downward, which means that the image A prime B prime is in an opposite direction with respect to the object AB, which means that the image A prime B prime is inverted with respect to the object AB. So let's write this down. The image A prime B prime is inverted with respect to the object AB. And now idea number 7. Because of this, we can deduce the nature of the image. So in this case, the image A prime B prime of the object AB, the image A prime B prime is real because it is inverted with respect to the object AB. So whenever the image is inverted with respect to the object, this means that the image is real. Okay. Moreover, we can say that idea 7.2, the object AB and the image A prime B prime are on opposite sides. So notice that here the object AB is in front of the lens, whereas the image A prime B prime is behind the lens, and whenever the image and the object are on opposite sides of the lens, this means that the image is real. So I repeat, the image here in this case is real because of two reasons. The first one is that the image A prime B prime is inverted with respect to the object AB, and the second one is that the object AB is in front of the lens and the image A prime B prime is behind the lens, which means that the image and the object are on opposite sides, therefore the image is real. Okay, so this is the formation or the construction of a real image. Now let's check the formation of a virtual image. Okay, here we have the optical system of a converging lens also, because we know that a converging lens can give a real image and a virtual image. Now we need to construct the virtual image given by this lens. So x prime x is the optical axis having the same direction of propagation of light, which is from left to right. And the lens here that we are using is a converging lens perpendicular to the optical axis at the optical center O. Okay, now AB is a luminous object. Let's write this down. AB is a luminous object placed in front of a converging lens L. Okay, now because the direction of propagation is from left to right, then this side is set to be in front of the lens and this side is set to be behind the lens. Okay, we have that AB is a luminous object placed in front of the lens. Okay, it's perpendicular to the optical axis at the point A. Now, because AB is a luminous object, which means it's made up of light, so it can emit light in all directions like this. But because the direction of propagation of light is from left to right, then we are only interested in light rays that are issued from left to right. Okay. So the first incident ray, which is issued from the point B, is parallel to the optical axis. We know that it will emerge passing through the image focus. And the second ray issued from B is passing through the optical center. We know that it will emerge without deviation. And finally, we need to trace the third ray, which is incident from B and passing through the object focus. Now notice that this ray cannot pass through the object focus because it's propagating from left to right, and the object focus is on the left of the object, which is in front of the object AB. So this ray cannot propagate backward to pass through the object focus. So we use the well-known trick is that whenever the incident ray cannot pass through the object focus, it will be issued in such a way that is along the direction of the prolongation between F and the point B. Okay, and we know that always incident ray related to the object focus, it will emerge parallel to the optical axis. Okay, then incident luminous rays are issued from B emerges through the lens. Okay, so idea number one, what does the point P represent? The point B represents the intersection of the incident rays. These rays are the incident rays because they are hitting the lens. So let's write down the object B of B prime is the intersection of the incident rays. And idea number two is that the point A represents the foot perpendicular of B on the optical axis. Then let's say A is the foot perpendicular of B on the optical axis. And here the point B prime, from the title it represents the image. Okay, image of which point? Of the object B. So notice that here the emergent rays, these are the emergent rays because they are coming out from the lens, and in order to obtain the image, we require for these incident rays to intersect. But notice that this is in front and this is behind. They don't intersect behind the lens, and in order to obtain the image, we require for these rays to intersect. So in order for these rays to intersect, we need to prolongate them backward. Okay, this is the prolongation of the first emergent ray, and this is the prolongation of the second emergent ray, and this is the prolongation of the third emergent ray. Okay, and in this case, the prolongation, the intersection of the prolongations will be the image B prime of the object B. So B prime, this is B prime, the intersection of the prolongations. Let's write idea number three, that the image B prime of B is the intersection of the prolongations of the emergent rays. Notice that here a hat is found on B directed away from the optical axis like this. Then we must place a hat on B prime directed away from the optical axis like this. So let's place the hat on B prime. Now moreover, the point A represents the foot perpendicular of B on the optical axis. Therefore A prime will also represent the foot perpendicular of B prime on the optical axis. Then let's write down idea number 4, that A prime is the foot perpendicular of B prime on the optical axis. So idea number 5, notice that now let's trace the image. Okay, now because B prime is the intersection of the prolongation of the emergent rays, this is the point A prime, the foot perpendicular of B prime on the optical axis, and now let's trace the image A prime, B prime. Because B prime is the intersection of the prolongation of the emergent rays, then we trace A prime, B prime to be dotted like this. Okay, so now let's get back to idea number 5. Notice that all of these emergent rays emerges from the lens as if coming from B prime, and this comes from the fact that all incident rays issued from which point? From B emerges as if coming from B prime. Okay, so all of these emergent rays emerges as if coming from the point B prime, and this happens not only from these emergent rays that are coming from these particular incident rays, in fact for any incident ray issued from B. So for example, if we consider an incident ray issued from B hitting the lens at this point, so we know only how to complete the path of 3 particular rays, but now after we know the image B prime of B, okay, this ray will emerge through the lens as if coming from B prime. Therefore we connect this point with B prime to be dotted. Then this ray will emerge as if coming from B prime like this, along the direction of the prolongation of B prime with this point. And we don't forget arrows on emergent rays. Okay, so also if we consider this ray issued from the point B prime, because we know the image B prime of B, this ray will emerge as if coming from B prime. Therefore let's connect the point B prime with this point, and this ray will emerge along the direction of the prolongation like this. Okay, let me do it like this. Now idea number 6. So notice now that the object AB is pointing upward and the image A prime, B prime is pointing upward, which means that the image and the object are in the same direction, which means that the image is erect with respect to the object AB. And the word erect means that it is in the same direction. So the image A prime, B prime is erect with respect to the object AB. And now idea number 7. Now we can deduce the nature of the image A prime, B prime. So in this case the image A prime, B prime is virtual, because 7.1. So the object AB is pointing upward and the image A prime B prime is pointing also upward, which means that the image is erect with respect to the object, which means that the image is virtual. So the first reason why the image is virtual, because it is erect with respect to the object AB. And the second reason is that, notice that this side is set to be in front of the lens, and the object AB and the image A prime B prime are on the same side of the lens, which is in front of the lens, which means that the image is virtual. So let's say that the object AB, because the image A prime B prime is virtual, because the object AB and the image A prime B prime are on the same side. And by this we have finished the construction or the formation of a virtual image. Now it's convenient to consider all the different cases of construction. So let's consider the construction of the image A prime B prime of AB, which is given by the first case. Okay, so section number 3. L is a converging lens of object focus f and image focus f prime. A luminous object AB is placed perpendicular to the optical axis x prime x at A in front of the object focus f at a distance greater than 2f. Okay, so number 1, they are telling me construction of a ray issued from B and parallel to the optical axis. And the word construct or constructions means that we need to trace and justify. Okay, we need to trace a ray issued from B and parallel to the optical axis. So this is an incident ray issued from B and parallel to the optical axis. We know that this ray will emerge passing through the image focus like this. Okay, and we don't forget arrows on light rays, incident rays as well as emergent rays that indicate the direction of propagation of light, which is from left to right. And construction means that we need to trace and justify. Now let's do the justification. So the justification is given by an incident ray issued from B. From which point? From the point B, because here they are telling me issued from B, and issued from B parallel to the optical axis, emerges passing through the image focus. So this is it for part 1. Now in part 2 they are telling me construction of a ray issued from B and passing through the optical center, and I repeat that the word construct means that we need to trace and justify. So this is an incident ray issued from which point? From the point B and passing through the optical center. Okay, and we don't forget arrows on light rays, incident ray as well as emergent ray. So this is the tracing. Now let's do the justification. Okay, an incident ray issued from B passing through the optical center emerges without deviation. Okay. And now for part 3, they are telling me construction of a ray issued from B and passing through the object focus. So we need to trace and justify the path of a ray issued from B and passing through the object focus. So this is an incident ray issued from B and passing through the object focus. We know that always incident ray passing through the object focus is related to parallel emergent ray. So this ray will emerge parallel to the optical axis like this, and we don't forget arrows on light rays, incident rays as well, emergent rays that indicate the direction of propagation of light. So now let's do the justification. An incident ray passing through the object focus. Sorry, let's say issued from B. An incident ray issued from B passing through the object focus emerges parallel to the optical axis. Okay. And now idea number 4 or part 4, they are telling me construction of the image B prime of B. Okay. As a general rule, always the intersection of the emergent rays is the image of the object. Okay. So these emergent rays are coming from these incident rays that are coming from the point B. Therefore, the intersection of these emergent rays will be the image of the object B. Therefore, this is the point B prime. Now a hat is found on B directed away from the optical axis like this. Then we must place a hat on B prime. So B is directed like this, the hat. Then we must place a hat on B prime directed away from the optical axis like this. So this is the hat. And now the word construct means that we need to trace and justify. So we already have done the tracing of B prime. Now let's do the justification. What does the point B prime represent? So then the image B prime of B is the intersection of the emergent rays. And now in part 5 they are telling me construction of the image A prime of A. Now the point A represent the foot perpendicular of B on the optical axis. Therefore A prime will also represent the foot perpendicular of B prime on the optical axis. Okay, and now let's trace the image A prime B prime. So this is the tracing of the image A prime, or in other words the image A prime B prime. Now let's do the justification. Okay, A prime is the foot perpendicular of B prime on the optical axis. Okay, and now in number 6 they are telling me the distance d between A, B and L. So in other words, we need to calculate the distance d between the object AB and the lens L. So now d consists of 1, 2, 3, 4, 5, 6 divisions, and we multiply by the scale along which we have counted the number of divisions, which is scale along the x-axis. Okay, this will give me 36. Since the scale is in centimeters, then the value of d will be in centimeters. So the distance object length is equal to 36 centimeters. And now they are telling me in number 7 to calculate the distance d prime between L and A prime B prime. So this distance represents the distance between the lens and the image, and it consists of 1, 2, 3 divisions, and we multiply by the scale along which we have counted the number of divisions, which is scale along the x-axis. This will give me 18. Since the scale is in centimeters, then the value of d prime will be in centimeter. Therefore, the distance between the lens and the image is given by 18 centimeters. And now they are telling me to calculate the size of the object AB. So the size of the object AB denoted by AB is equal to, now AB consists of 1, 2 divisions, and we multiply by the scale along which we have counted the number of divisions, which is scale along the y-axis, which is 2. This will give me 4. Since the scale is in centimeters, then the value of AB will be in centimeters. So the size of the object AB is equal to 4 centimeters. And now in number 9, they are telling me to calculate the size of the image A prime B prime, which is denoted by A prime B prime, and it consists of 1 division, and we multiply by the scale along which we have counted the number of divisions, which is scale along the y-axis, which is 2. This will give me 2. Since the scale is in centimeters, then the value of A prime B prime is in centimeter. So A prime B prime is equal to 2 centimeters. And now in number 10, they are telling me to compare AB and A prime B prime. So whenever we need to compare two numbers, we need to say whether one is greater than the other, or equal, or less than. So the size of the object AB is given by 4 centimeters, and the size of the image A prime B prime is given by 2 centimeters. And as you can notice that the object AB is larger in size when compared to A prime B prime, which means that AB is greater than A prime B prime. And now in number 11, they are telling me the direction of the image A prime B prime, so we need to say whether it's inverted or erect. So notice that here the object AB is pointing upward and the image A prime B prime is pointing downward, which means that the image A prime B prime is inverted with respect to the object AB. So let's say that it is inverted with respect to the object AB. And now finally in number 12, they are telling me nature of the image A prime B prime. So from number 11, we know that the image is inverted with respect to the object AB, and we know that whenever the image is inverted with respect to the object AB, then the image is what? Real. So let's say real, since it is inverted with respect to the object AB. One could give another reason why the nature of the image is real. So notice that here the object AB is in front of the lens. So this side is said to be in front of the lens, and this side is said to be behind the lens. So the object AB is in front of the lens and the image A prime B prime is behind the lens, which means that the image and the object are on opposite sides of the lens. And whenever the image and the object are on opposite sides, this means that the image is real. So since the object AB and the image A prime B prime are on opposite sides. So by this we have finished section 3 of chapter 2. Okay, that's it for me in this video, guys. In part 2 we will complete the